Hello and welcome back to this channel. Dear students, today's topic is FR filter design using Windows. This is the topic from the subject Digital Signal Processing, that is DSP. Actually, these are pretty simple numericals. I will tell you the trick. If you solve one numerical, then all the numericals are of same types, only equations will be changed. Now, as far as window method is concerned, there are four major types of windows on which we are supposed to solve the numericals. First is rectangular window. I have written the formula of each window. Notation is WR of n. Its value is 1. Second is Henning window. Hanning. Henning window. Its formula is 1 by 2 in the bracket 1 minus cos 2 pi n upon m minus 1. Here the notation m indicates order of filter. Next is Hamming window, Hamming. Notation is WHM of n. This is the formula 0.54 minus 0.46 cos of 2 pi n upon m minus 1. And last is triangular or Bartlett window. Notation is WB of n. Formula is 1 minus 2 mod n upon m minus 1. In all calculations, range of n or variable n varies from 0 to m minus 1, where m is the order of the given filter. Now, you just have to follow the simple steps. First step will be calculate HD of omega. HD of omega is known as desired filter response or desired frequency response. It is given by e raised to minus j omega m minus 1 by 2. In the earlier video, we have already derived this formula. Second, calculate, this is first step. Second step is obtain HD of n by taking IFT. IFT stands for inverse Fourier transformation. This is the formula to calculate IFT. We'll solve the numerical, then these steps will be more clear to you. And last step, calculate H of n, which is given by HD of n, which we will be calculating in step 2. Multiply by window equation. Window equation means any one of the equations which will be mentioned in the question. Apart from this, we need to make use of one identity to solve this numerical, that is sin theta is e raised to j theta minus e raised to minus j theta upon 2j. Now, let us solve the numericals to get an idea. As I mentioned, every numerical is similar, only equations will be changed. So first problem, design linear phase FR filter of length 7. As I rightly mentioned, length is given by notation m, so m is equals to 7. Cutoff frequency 1 radians per second. Cutoff frequency is denoted by omega c, which is 1 radians per second, using rectangular window. Now step 1. In step 1, what I said, we have to calculate HD of omega. So I will write the formula. HD of omega is equals to e raised to minus j omega m minus 1 upon 2. Given value of m is 7, so simply put the values. So it becomes e raised to minus j omega 7 minus 1 upon 2. This gives me e raised to minus j 3 omega. 7 minus 1 is 6 upon 2 is 3. So e raised to minus j 3 omega. This is answer of first step. Step 2. In step 2, what I am supposed to do, I have to calculate inverse Fourier transform. This is the formula to calculate inverse Fourier transform. So first I will write the formula. HD of n is 1 by 2 pi integration minus omega c to plus omega c HD of omega e raised to j omega n d omega. We have to put the given values. Given value of omega c is 1. So this becomes 1 by 2 pi as it is, integration minus 1 to plus 1. HD of omega means I need to put this value of HD of omega, that is e raised to minus j 3 omega into remaining term as it is, that is e raised to j omega n d omega. Let us simplify this further, so it can be written as 1 by 2 pi integration minus 1 to plus 1. I will combine these two terms. So it can be written as e raised to j omega n minus 3 d omega. Very simple. What I did, from these two terms, I have taken j omega common. So e raised to j omega is taken common. First term, inside the first term, only remaining term will be minus 3, and in the second term, remaining term will be n when you take e raised to j omega common. So I have written it as n minus 3 d omega. Say this is equation number 1. I have to solve this integration, therefore I will write it like this: hd of n is equals to this 1 by 2 pi as it is. Answer of this integration is very simple trick. Variable of integration is omega, so first e raised to term you need to write it as it is, divided by. What is variable of integration? It is d omega, so skip omega term. So from the power of e, skip omega term, divide this equation, divide this quantity by the remaining term, so it is j upon n minus 3. Very simple trick to solve such numericals, such integration. Keep e raised to j term as it is. Variable of integration is omega, skip omega term, divide this equation by the entire term. So it is j n minus 3. Now, I have to convert it in terms of sign. We need to make use of this formula. So, to convert it in terms of sine wave, formula of sine, in the denominator I need to have 2j. So I will rearrange this equation. I will write it like this: 1 by pi n minus 3 in the bracket e raised to limits are minus 1 to plus 1. So e raised to j omega n minus 3 upon 2j. Limits are, again I haven't yet put the limits. Limits are minus 1 to plus 1. What I did, this n minus 3 is taken out, 2 is taken inside the bracket to adjust the value, to get the value 2j in the denominator. Now, in place of omega, this I have to put upper limit and then lower limit. So, next equation can be written as hd of n is equals to 1 by pi n minus 3 in the bracket e raised to j. In place of omega I am putting 1, so j n minus 3 minus e raised to, now in place of omega I am putting minus 1, e raised to minus j n minus 3 upon this denominator term 2j as it is. I have to make use of this formula. In this formula, it is e raised to j theta. Look at this equation. Here you can say value of theta is n minus 3 to make use of this formula. So this answer can be written as hd of n is equals to 1 by pi n minus 3 into sine, look at the formula, it is sine theta and theta is n minus 3, sine of n minus 3. This is the answer of hd of n, say equation number 2. Now one important step. Up till now it was very straightforward. I have simply solved the integration term. In every window numericals, after simplifying, after getting this answer will not be valid for n is equals to 3. So I will write it, this is not valid for n is equals to 3. Symbol is like this, n not equals to 3. Why it is so? We are supposed to put the value of n. As I mentioned earlier, n varies from 0 to m minus 1. In this case, m is 7, so n varies from 0 to 6. But if you put n is equals to 3, you will get sine 3 minus 3, sine 0. Sine 0 is 0 divided by. Here, if I will put 3, it becomes 3 minus 3, that is 0. So 0 upon 0 is meaningless. So how to remember this thing? In every window numerical, whatever term you are getting inside a sine term, here I am getting n minus 3. Constant is 3, so directly write it is not valid for n is equals to 3. Now, for n is equals to 3 it is not valid, but for all remaining values it is valid. To get the value for n is equals to 3, put n is equals to 3 in equation 1. Look at this equation. This is equation 1. In equation 1, I will have to put n is equals to 3. So if you put n is equals to 3, this becomes e raised to j omega 3 minus 3. 3 minus 3 is 0. So this term becomes, I will do it here, 1 by 2 pi integration e raised to 0 d omega, limits are minus 1 to plus 1. Because n minus 3 I'm putting n is equals to 3. 3 minus 3 0. So you are getting e raised to 0. E raised to 0 is 1. So this becomes 1 by 2 pi integration of d omega. 1 into d omega is d omega only, minus 1 to 1. So this can be written as 1 by 2 pi integration of d omega is omega. Limits are minus 1 to plus 1. Put the limits, so it becomes 1 by 2 pi upper limit 1 minus of lower limit minus 1. So 1 minus of minus 1 becomes 2. This 2 and 2 gets cancelled. So hd of n is equals to 1 by, this becomes 2, 2 and 2 gets cancelled. So answer is 1 by pi. So this is the answer for n equals to 3. This is very important step. As I mentioned right now, in every sum you will come across this situation that for one particular value and the answer of hd of n will not be valid. So you need to calculate that particular answer by referring equation number 1. This is valid, this is applicable for every sum. Now the last step. In the last step, that is, this was the step 2. In third step, what you are supposed to do? I will write here step 3. You are supposed to make one table like this. First column is, I will remove this part because we have already done the calculation. So first part is value of n. As we mentioned, n varies from 0 to m minus 1, that is 0 to 7 minus 1, so it varies from 0 to 6. So first is value of n. Second, hd of n. In the table itself, be habitual of writing the formula. We have derived this formula. It is 1 by pi n minus 3 sine of n minus 3. This is for n not equals to 3, and we have one more answer, 1 by pi. This is 1 by pi for n is equals to 3. This is the second column. I will be calculating value of hd of n. Third column, wr of n. Now we have already discussed value of rectangular window is 1 for all values. So everywhere I will write this value equals to 1. Third term, h of n is equals to, I will have to refer this formula, hd of n into window equation. So this becomes hd of n into wr of n. How to fill the values in the table? Very simple. First value n is equals to 0. So for the first value n is equals to 0, make use of this formula. One important part. Throughout this subject DSP, keep calcium radian mode, because we will be doing calculations related to value pi. So always and always keep calcium radian mode. Without fail, check the mode of calculator. So answers will not be wrong. Wherever n is there, put value of n is equals to 0. So first calculation I will explain. 1 by pi 0 minus 3, that is 1 by minus 3 pi into sine of minus 3. Do this calculation on the calculator. So this value, this answer will be 0.015. This is the first answer for n is equals to 0. WRN is 1 for all values. So take simple multiplication of these two terms. So 0.015 into 1 becomes 0.015. Then put next value. Next value of n is 1. Same way, wherever n is there in this equation, put n is equals to 1. So you will get sine of 1 minus 3 divided by pi 1 minus 3. Solve it on the calculator. This answer will be 0.145 into 1 becomes same 0.145. Next value 2. For 2, again wherever n is there, put value equals to 2. This value, this answer will be 0.268. So into 1 becomes 0.268. For value 3, now a common mistake. We have derived separate equation for n is equals to 3. Don't make use of this formula. So it is 1 by pi. So answer is 1 by pi. If you solve this 1 by pi, you will get answer 0.318. Next value 4. Now I will tell you one trick. You don't have to do the calculation till 7. you have already done the calculation till the middle part, that is till the value of 3. After that, values repeat. That means value of 4 will be same as this value, earlier value. So this answer is 0.268. Then value of 5 will be same as this value, 0.145. Value of 6 will be same as this value, 0.015. So every time value of WRN remains 1. So these values remain same, 0.318, 0.268, 0.145 and 0.015. That's it for this numerical. See, what you are supposed to do, very important part, don't waste your time for doing calculation till the end. Do the calculation till the center part. After that, values repeat in reverse way. That means after 0.318, after 3, value of 4 is same as this value of 2, value of 5 is same as value of 1, value of 6 is same as value of 0, and so on. So this is the numerical related to rectangular window. We will solve one more numerical related to different window. What will be the change? The table remains same. This formula will be different and you will be having some equation of that particular window which is asked in the question. Otherwise, all remaining steps will be same. The next numerical is define design FIR filter using Hamming window, HAMMING, for HD of omega is e raised to minus j3 omega and this is the given frequency range. What's the difference between this problem and earlier problem? In earlier problem, we calculated the value of HD of omega. In this case, it is given. But in this numerical, value of m is not given. First step is I need to calculate value of m. M is the order of filter. How to do it? We have this formula, this standard formula. So below this I will write the standard formula. HD of omega is e raised to minus j omega m minus 1 upon 2. Compare this formula with the given equation. So I can write it like this. This e raised to minus j is common in all the terms. So I will write it like this. Omega, this omega m minus 1 upon 2 is equals to 3 omega. Omega gets cancelled. So m minus 1 is equals to 3 into 2, 6. Therefore, m is equals to 7. So I got the value of m, that is equals to 7. This is the first step what we did in case of this numerical, because value of m was not given. So we calculated value of m. Now, this step is not required because HD of omega is already given in this question. So I will directly start the numerical by this step, that is calculation of inverse DFT. So inverse Fourier transform. So it is HD of n, formula is 1 by 2 pi integration minus omega c to plus omega c. This is HD of omega. HD of omega is given in the question. I will directly put the value e raised to minus j 3 omega into e raised to j omega n as it is d omega. All the remaining steps are same like the previous sum, only values are different. So it is 1 by 2 pi limits. See, minus omega c to plus omega c means these given limits we have to put. So minus pi by 4 to plus pi by 4. This is e raised to j omega n minus 3. Like the last sum, I have taken e raised to j omega common, n minus 3 into d omega. As I mentioned earlier, all the things are same, only values are different. So it can be further simplified as 1 by 2 pi. This integration answer I will directly write e raised to j omega n minus 3 upon j n minus 3, which is pretty similar to the earlier problem. Limits are different, that is minus pi by 4 to plus pi by 4. To convert it in terms of sign, make the rearrangement like the last sum. So I will write it like this: 1 by pi n minus 3 in the bracket e raised to j omega n minus 3 upon, what I am supposed to do, this n minus 3 is taken out, transfer this 2 inside this bracket. So divided by 2j, limits are minus pi by 4 to plus pi by 4. Put the limits, so it is 1 by pi n minus 3. In place of omega, I have to put the limits, so e raised to j pi by 4. In place of omega, I am putting upper limit pi by 4. N minus 3 remains as it is, minus e raised to. Now put lower limit is minus pi by 4 in place of omega. So e raised to minus j pi by 4 n minus 3 upon 2j. Like the earlier sum, this answer can be directly written as 1 by pi n minus 3 sine of pi by 4. With j, I have disturbed pi by 4 n minus 3. So, while making use of this formula here, theta means pi by 4 n minus 3. So, it is sine theta. So, it is sine pi by 4 n minus 3. This is the answer. As I mentioned earlier, every answer is not valid for one single value. How to identify that value? In the bracket, I have n minus 3. So this is not valid for n is equals to 3. It is written like this, for n not equals to 3. To get the value for n is equals to 3, again make use of this equation, say it is equation number 1. So in equation 1, I will write it here from equation 1, put n is equals to 3. So you will get answer hd of n is equals to 1 by 2 pi limits minus pi by 4 to plus pi by 4. After putting n is equals to 3, you will be getting 3 minus 3, that is 0. E raised to 0 is 1. So it is 1 into d omega. Put the values. So answer of d omega, integration of d omega is omega. Limits are minus pi by 4 to plus pi by 4. So this becomes 1 by 2 pi. Upper limit pi by 4 minus of lower limit minus pi by 4. So this becomes 1 by 2 pi in the bracket pi by 2. So these values gets cancelled. I mean pi gets cancelled. So it becomes 1 by 4. So this answer will be 0.25. This is the value of hd of n for n is equals to 3. This is the second step. Now, the last step, like the previous sum, in the last step, what I am supposed to do, I have to write the values in one table. There will be different columns in the table, like the last sum. First, I will draw the table. So, first part is value of n. N varies from 0 to m minus 1 like the last sum. So first value is 0, next value is 1, next value is 2. Likewise, you need to do this calculation up to the value 6. So this is the value of n which varies from 0 to 6. Now, in the next column, I have to put the value of hd of n is equals to. We already derived this formula, so write this formula directly, 1 by pi n minus 3 in the bracket sine pi by 4 n minus 3. This is the value of hd of n which we have already obtained. Next column is one more thing, this is the value for n not equals to 3. For n is equals to 3, we have solved this value, that is 0.25 for n is equals to 3. Next value is here, you need to write the formula for Hamming window, notation is WH of m, and this formula is 0.54 minus 0.46 cos of 2 pi n upon m minus 1. Now in this case, the last column will be different. So that last column will be, I will write it over here. H of n is equals to hd of n into WHM of n. That is multiplication of these two columns, second and third column. For your reference, I have written all the answers. Keep in mind the answer after central part, that is after 3, repeats in all the things. So these are the answers just for your ready reference. So that's it for this numerical. As I mentioned, only equations will be changed. Procedure remains same. So thank you. Thanks a lot for watching this video.